when you still see that sometimes, not all the time, but in a few occasions, the bond, you still have bond failures like non-stick failures or low pull force results. This may be because of the input materials, in the sense that whenever you not all the parts are contaminated the same, and so when you put them in the plasma chamber, if you do the plasma for always the same time, for example, you will only be able to reduce so much contamination. So what you want to do is, if you have high variability in the contamination in the input of the plasma chamber, you need to be sure that the plasma process is set up correctly so that no matter what comes in, it always comes out as a clean surface. So that's the first thing that I would try to investigate. The second thing is simply verifying the status of the machines, doing a health check of the machine, checking if there are any leaks in the plasma that may cause some oxygen leakage inside, and for some parts, then the plasma would not be as efficient. And then the third thing is wire materials. So checking that the wire is being supplied always by the same supplier with the same specs. And then on the wire bonder itself, verifying that the wire bonder is working correctly. We need to be able to have a plasma process which is powerful enough to clean the hardest frame to clean. If we can achieve that, then it doesn't really matter what comes in. We always can have a deterministic output where all the frames that come out of the plasma machine are correctly clean. You can have situations where some problems may arise at times and then they stop without any intervention. And so in that case, it's really, really hard to try to debug and find, to troubleshoot all the machines, all the process, and pinpoint whatever went wrong. This is generally true because you have to imagine that to produce a single part, you may have 20 steps in a certain line, and then you have 20 suppliers for the machines. I don't know how many suppliers for the materials. And so you have to imagine that one thing goes wrong in this huge system and it may cause the issue. Or one thing goes wrong there, which you cannot detect because it's still within spec, and then it generates something wrong 10 steps down the line. So you may have this kind of very, very hard to solve situations. It takes a lot of time to the engineers, the process engineers, to pinpoint them. And sometimes it's really, really hard. You have to imagine that every time the line stops, you're losing a lot of money because you're not producing anything and you don't want to be late and everything. So it's really stressful for production engineers when things go south and they are running at 100% capacity. They cannot afford any lost minute. Otherwise, they may miss their delivery targets. They also need support from your side. They need to know that if something goes wrong and they are under fire, they need to know that you will be there to support them as much as you can. So if the problem comes from your machine, you need to be there to help them solve the problem as soon as possible.